everyone, welcome to my channel Microbiology with Shabu. In this video we are discussing about sterilization and disinfection. So let's start. Sterilization. Sterilization is the process by which an article, surface or medium is free of all living microorganisms either in the vegetative or spore state. Disinfection. Disinfection means removal of all pathogenic organisms. Antisepsis. Antisepsis means the prevention of infection, usually by inhibiting the growth of bacteria in wounds or tissues. Agents used for sterilization. Physical agents under this: 1. Sunlight, 2. Drying, 3. Dry heat, which include flaming, incineration, hot air. 4th one, moist heat, which include pasteurization, boiling, steam under normal pressure, steam under pressure. 5th one, filtration. 6th, radiation. 7th one, ultrasonic and sonic vibrations. B. Chemicals, which include alcohols, aldehydes, dyes, halogens, phenols, surface active agents, metallic salts, gases. A. Physical agents. First one, sunlight. Sunlight has bactericidal and germicidal activity. The action is primarily due to its content of ultraviolet rays. 2. Drying. Moisture is essential for the growth of bacteria, so drying will affect most bacteria. Spores are unaffected by drying. 3. Dry heat. The killing effect of dry heat is due to protein denaturation, oxidative damage, and the toxic effect of elevated levels of electrolytes. Methods are: A. Flaming. Inoculation loop tips of forceps can be sterilized by holding in a Bunsen flame till they become red hot. B. Incineration. This method is used for destroying materials such as contaminated clothes and pathological materials. C. Hot air oven. This is the commonly used dry heat method and is widely used to sterilize glassware, forceps, scissors, swabs, glass syringes, etc. The oven is usually heated by electricity with the heating elements in the wall of the chamber. It has a fan for the distribution of air. A holding period of 160 degrees Celsius for 1 hour is applied here. 4th one, moist heat, which include temperature below 100 degrees Celsius. Pasteurization. Heat treatment of a perishable food, example milk, to destroy heat-sensitive vegetative cells, followed by immediate cooling to limit growth of surviving cells and germination of spores. There are two methods: holder method 63 degrees Celsius for 30 minutes, flash methods 72 degrees Celsius for 15 to 20 seconds. B. Temperature at 100 degrees Celsius, boiling. Vegetative bacteria are killed almost immediately at 90 to 100 degrees Celsius, but sporing bacteria require prolonged periods of boiling. C. Steam at atmospheric pressure, tintalization. Media containing sugar or gelatin can be sterilized by this method. An exposure of 100 degrees Celsius for 20 minutes on 3 successive days is used. Hence, when pressure inside a closed vessel increases, the temperature at which water boils also increases. Laboratory autoclave consists of a vertical or horizontal cylinder. On its lid, it has a discharge tap for air and steam, a pressure gauge, and a safety valve that can be used to set desired pressure. Usually 121 degrees Celsius for 1 hour is applied. Heating is by gas or electricity. Sufficient water is put in the cylinder. The material to be sterilized is placed on the tray and the autoclave is heated. The lid is screwed tight with the discharge tap opened. The safety valve is adjusted to the required pressure. The steam-air mixture is allowed to escape till all the air has been displaced. When no more air comes out, the discharge tap is closed. The steam pressure rises inside, and when it reaches the desired set level, the safety valve opens and the excess steam escapes. From this point, the holding period is calculated. When the holding period is over, the heater is turned off and the autoclave allowed to cool till the pressure gauge indicates that the pressure inside is equal to the atmospheric pressure. The discharge tap is opened slowly and air is let into the autoclave. Filtration. Filtration helps to remove bacteria from heat labile liquids such as syrup and solutions of sugars or antibiotics used for preparation of culture media. The following types of filters have been used: 1. Candle filters, 2. Membrane filters, 3. Asbestos filters, 4. Sintered glass filters. Radiation. Two types of radiations are used for sterilization: non-ionizing and ionizing. Chemical agents. Several chemical agents are used as antiseptics and disinfectants. Chemical agents act in various ways. The main mode of action are: 1. Protein coagulation, 2. Disruption of cell membrane. Alcohols. Ethyl alcohol and isopropyl alcohol are the most frequently used. They are used mainly as skin antiseptics and act by denaturing bacterial proteins. They have no action on spores. To be effective, they must be used at a concentration of 60 to 70% in water. B. Aldehydes. Formaldehyde has a bactericidal and sporicidal activity. It also has a lethal effect on viruses. Formaldehyde gas is used for sterilizing instruments and for fumigating wards, sick rooms, and laboratories. C. Dyes. Two groups of dyes, aniline dyes and acrylic dyes, are used extensively as skin and wound antiseptics. The aniline dyes in use are brilliant green, malachite green, and crystal violet. They are more active against gram-positive organisms than against gram-negative organisms. The acridine dyes in use are proflavin, acriflavin, euflavin, and aminacrin. They are more active against gram-positive organisms than against gram-negative, but are not as selective as the aniline dyes. D. Halogens. Iodine in aqueous and alcoholic solution has been used widely as a skin disinfectant. It is active against the tubercle bacteria and viruses. Chlorine and its compound have been used as disinfectants for many years. Water supplies, swimming pools, food and dairy industries use chlorine for disinfection. E. Phenols. Phenol is a powerful microbicidal substance. These are widely used as a disinfectants for various purposes in hospitals. F. Gases. Ethylene oxide. It has been successfully used to sterilize a wide range of materials such as heart-lung machines, dental equipment, glass, metal and paper surfaces, clothing, plastics and soil. Formaldehyde gas. This is widely employed for fumigation of operation theatres and other rooms. Surface active agents. These are widely used as wetting agents, detergents and emulsifiers. They are classified into four main groups: anionic, cationic, non-ionic and amphoteric. The most important antibacterial agents are cationic surface active agents. Metallic salts. Though all salts have a certain amount of germicidal action depending on their concentration, salts of heavy metals have great action. The salts of silver, mercury and copper are used as disinfectants. Thank you so much for watching my video. Stay subscribed for the next video.